Welcome to Pre-AMC Week 5, Problem 1. The diagram shows 5 congruent right-angled isosceles triangles. So what is total area of the triangles? So, okay, we have 5 isosceles right triangles here. It's obvious this angle is 90 degrees. So then we have 5 hypotenuses connect to each other and form a line which length is 30 centimeters. So each hypotenuse, then it is 6 centimeters. 6, 6, 6, 6. Okay, so then let's put 4 of these right triangles, put it like this way. Okay, so it's actually form a square. That is because these isosceles right triangle, this angle is 45 degrees, this is 90 degrees. So 45 degrees. 2 of 45, so then this is 90 degrees too. 90 degrees, 90 degrees, same here, 90 degrees. So, and the side length is the length of the hypotenuse is 6, 6. 6, 6. Okay, so then we have area of square equals to 6 times 6, 36 centimeters square. And the area of one triangle, right triangle, is 36 divided by 4 because we have 4 right triangle form one square. Okay, so it's 9 centimeters square. So then we have 9, 9, 9, 9. And area of, we need to calculate 5 of these right triangles. So 5 triangles is 9 times 5, 45 centimeters square. Okay, the answer is D then. Problem 2, the average of 9 numbers is 9. If one number is changed to 9, the average becomes 8. So what is the original value of that number? Okay, so we have 9 numbers. 4, 5, 6, 7, 8, 9. So then the average is 9. So the sum of these 9 numbers would be average times 9 numbers, 81. Okay, so then we have one number changed to 9. For example, this number, other numbers stay the same. So then we have new sum is 8 times 9 is 72. So the difference is actually 81 minus 72 is 9. So this new sum is 9 less than the old sum. So how come the new sum has 9 less than the old sum? Is that because this number changed to 9? So that means this number subtract 9 becomes this new number, new value, 9. So what is the original value of this number? So it would be 9 plus 9. We need to plus this 9 back equals 18. So the original value of this number actually is 18, right? So it's D. Problem 3. Which of the following fraction is in the middle way between 1 over 5 and 1 over 3? Okay, let's draw a number line. So say 1 over 5, fraction is here. And the 1 over 3, the fraction is here. So because 1 over 3 is greater than 1 over 5, right? So the midway could be here. Okay, so what is this point, the fraction? What fraction of this point? Okay, so let's convert it 1 over 5 to 1 over 3 to have the same denominator. So the common denominator of 5 and 3 is 15. So then we have 15, and 1 over 5 is 3 over 15. And 1 over 3 is 5 over 15. Okay, then it's obvious the middle way would be 4 over 15. So the answer is C. Problem 4, Greg sees a clock in the mirror where it looks like this. So what is actual time? So because this is the image, we look in the mirror, so the real clock, so we need to flip this mirror, or flip this image. So let's draw here. So then we have a clock. So the 12 should look like this now. Okay, so because we flip it, so this minute finger should point to here. Okay, so the hour finger would point to here. Okay, so what time is this? 10 or 7:10. The answer is E. Problem 5. N is the smallest positive integer whose digits add up to 50. So what is the remainder when n is divided by 7? So okay, so let's find out what is n first. So the n is smallest positive integer whose digits add up to 50. So digit should be 0 to 9. So n should have the least number of the places. So let's just add each place and the number as large as possible. So it would be 9. Okay, so then we have 5, 9 add up to 45. So we still need a 5. So because n is smallest positive integer, so let's put a 5 in this place. So then we have 599,999. So that is the smallest positive integer, and the digits add up to 50. So then next step, let's find out the remainder when n is divided by 7. So we have 599,999. So we divided it by 7. Okay, 8, 56, 39, 5, 35, and 49. Okay, 7, 49, good, 9, 7, so 29, 4. Okay, so remained is 1, which the solution answer is B. Problem 6, in the following 2 times 2 grid, what is the number of shortest passes to walk from lower left corner A to the up right corner B? Okay, so we need to walk from A to B. Okay, and we need to find out how many possible ways of the shortest passes. So A to B shortest pass, we can take a look at this 2 times 2 grid. So at least 4 steps, right? So 2 steps goes up. So 2 steps goes right. Okay, just like this example, the red one, okay? Up, right, up, right. Okay, so let's list all the possible ways. Okay. Let me draw 6 of the 2 times 2 grid. So actually there are 6 ways. Okay, the pass will be in red. Okay, so the first one, we can walk like this. The second one, we can work like this. Or we can work like this. And the fourth one, we can work, oh, okay, sorry. Okay, no red here. So we can work like this, or we can work like this, and the last pass. Okay, so total 6 passes, shortest passes. So would be D. Problem 7. Positive integers are arranged in a way such that the nth group has n consecutive numbers. So for example, the first group is 1, second group is 2, 3, and the third group is 4, 5, 6. So on which group is the number 100 in? Okay, so we have groups, okay, so 1, okay, so numbers in the group. So how many numbers in the group? This is only one number. So we have 2, 3, let's just have 2 number, and 4, 5, 6, 3 numbers, and 7, 8, 9, 10, right? 4 numbers. So it will go on, so like this. Okay, so then let's add these numbers in each group. Okay, so for the second group, so we add first group's how many numbers in the first group, and how many numbers in the second group. So if we add 1 plus 2, 3. So then if we add from the first group to the third group, equals 6. So for 10. So you can see the last number actually it's the same as the number in each group. So let's say we have a group, okay, and we don't know, but we like it to contain 100. So we don't know which group it is and how many numbers in this group. And we know actually we need to do the same thing as this step. 1 plus 2 plus 3 plus a question mark should be close to 100. So what is this question mark? So let's try, okay, let's try 10 first, okay? So we have 1 plus 2 plus 3 and plus 2, 10. So we know how to calculate this sum, right? So 1 plus 10 and 10 terms divided by 2. So which is 11 times 5, 55. Oh, not close to 100 at all. So maybe let's try 15. Okay, so 15 would be 1 plus 15 times 15 over 2. So it's a 16. 16 divided by 2 is 8 times 15. So 120. Okay, so that is greater than 100. So then we know our group should be between 10 and 15. Okay. Should be between 10, question mark group, 10 to 15. Okay, so let's try maybe 13. So that equals 1 plus 13, 13 divided by 2. So 7 times 13, 91. So, okay, so actually we can say there is a group. The 13 group is very close to 10 already. And this 13 group, let's say, okay, let's erase some of these. Okay, so then we have 13 group. Okay, so basically is this 13 group has a last digit, last number is 91. And the total number is 13. So we have 1 plus 2 plus 3 and plus 2 13 is equals 91. So then next group, okay, so the next group, okay, the next group will start as 92. So 93, right, would have 14 numbers. So of course, we will have 100. We will have 100 in the middle somewhere. Okay, so then the 14th group would have 100 in it. So the answer is D.